is Zen, and for the CS6077 project, the topic I'm doing is the top anime list. The dataset is given by the Kaggle. It's, as you can see, it's distributed as score, popularity, rank, members, description, Japanese and English name, and other, as well as other categories for the dataset. Uh, this is just a summary table on what's being listed, and of course what are our major concern for the entire table. So what I did with the data set is I run three different classifiers that we all know of. We will run the models on the data set and run the accuracy and confusion matrix. And after that, we will compare uh, these three classifiers reports to see which one actually comes to close to what we would imagine for the table for um, people who are watching anime. And of course, we're trying to draw a short summary on which one works the best, and also what can we see, what can we tell from the table. So the first one is the logistic regression. The logistic regression classifier performed pretty good on the test set, achieving an accuracy of 98%. The main idea for the logistic regression classifier on the data set is to see from the perspective of precision, and also the measure the ability for the model to find all the positive samples as well as the F1 score. So the precision for the top tier class, the precision is like 100%. So all enemies predicted as top tier were indeed top tier. Um, the top tier class for the model to find all positive samples are the recall is 80%, which means the model correctly identified 80% of all actual top tier enemies. And the F1 score, it's 0.89, which is very high later on when you see the other two classifiers. This is the picture what you have as on the distribution of enemy scores as well as the popularity versus score. You can see from there that on the distributivity of popularity versus score, it kind of shows like the lower is the better. And you can see that the green means the top tier 1, and the red means top tier 0, which indeed that the score are heavily distributed, you know, on the left. And on the frequency of the distribution of enemy scores, you can just see that most of the enemies that scored lower are more they have a large group set. And the next classifier I did with is decision tree. First I did, of course, is to include more categorical features and also tune the hyperparameter like max depth and minimal sample split. And so after we run the model, the best parameters found were max depth, which is of 30, minimum sample split has 1, and minimum sample split has 2. The best score obtained from the cross validation is approximately 48%, and the accuracy model on the test it was improved to 51%, but before that it was roughly 40%. So this is the confusion matrix on what you have for the model. You can see that compared to linear regression, the accuracy dropped like significantly. The third classifier that I run through with is the SVM. So for the SVM classifiers, I did the true, negative, false, positive thing, as well as a confusion matrix with it. So the true negatives comes to 4, which means the model correctly predicted 4 animes as low rated. False positive has like 68, so it incorrectly predicted 68 animes as high rated when they're not. As well as false negative only has 2, which incorrectly predicted 2 animes as low rated when they were high rated. and true positives has 126, which means the model predicted 126 enemies as high rated. So we can also see that for the SVM classifiers, the accuracy is still not as good as logistic regression, but it is way better than this is decision tree, and now it's therefore the decision tree model is already being improved. So we can see that for I would say for this type of data set, we would definitely try go for logistic regression. A, for it's simple to use, it's the model itself is less complicated. Secondly, B, the reason that why it would have such a high accuracy is probably because for the data set, most of the data is more like linearly related. They don't really have like a very inner relationship, or a very complicated one to go with, which is why in this case logistic would actually give out the best result. And of course, for the dataset itself, we can conclude that high fantasy setting with epic battles and magical elements would probably rank, higher, probably the highest. And after that, you have second tier rank, which is like more futuristic cityscape with advanced technology and cybernetic enhancement. And third popular type of animes will probably be like those featuring traditional Japanese settings and mythical creatures, which I would say this conclusion is pretty much the same what I would predict, as I myself do watch a lot of animes, and so I do understand that I would say this result is kind of expected. That's it for all. Thank you very much.